Ever pasted the exact same prompt into, say, ChatGPT and Claude, and then just stared at your screen wondering why the token counts are completely different? Yeah, it's a super common. And let's be honest, a really frustrating problem if you're building with AI. But you're not going crazy. The numbers are different, and there's a good reason why. Let's break it all down. So here's how we're going to tackle this. First, we'll dig into the mystery itself. Then, we're going to meet the main character in the story, the tokenizer. After that, we'll explore exactly why they can't seem to agree, what that means for your wallet, and finally, we'll lay out a solid strategy for dealing with it all. All right, let's dive right in. We're going to start with the core problem, the thing that trips up so many developers when they're trying to forecast costs or just, manage their prompts effectively. Okay, so picture this, because you've probably lived it. You have a piece of text, your prompt. You pop it into ChatGPT. It says 100 tokens. Great. Then you take that exact same text over to Claude, and suddenly it's 115 tokens. Now, a 15% jump might not seem like a huge deal, but when you scale that up across thousands of API calls, whoa, it adds up fast. So that brings us to the big question, right? What gives? How can two incredibly sophisticated AI models look at the very same string of characters and come to a totally different conclusion about what it's made of? Well, the answer lies in this hidden but absolutely critical piece of the puzzle. So, let's pull back the curtain and meet the component that's responsible for all this confusion. It's called the tokenizer. It's kind of the unsung hero of the whole operation, or, the villain, depending on how you feel about your latest API bill. To put it simply, a tokenizer is basically a translator. It takes our language, words, sentences, punctuation, even code, and it slices it up into smaller pieces, these tokens, that the AI can actually understand and work with. Without a tokenizer, the LLM would just see a jumble of letters. The best way to think about it is like a custom dictionary. Every single LLM gets its own unique dictionary that defines the building blocks of language it was trained on. And just like a Webster's dictionary is different from an Oxford, each of these AI dictionaries is just a little bit different from the next. And this is where we get into the nuts and bolts of it. Why are all these dictionaries so different? It's not random at all. It really comes down to the specific rules they were built with and the data they learned from. The disagreement really boils down to three core things. First, the size of their vocabulary. Second, the different algorithms they use to actually do the chopping. And third, how they deal with all the weird stuff that isn't just a simple word, like spaces, punctuation, and especially code. Let's start with vocabulary size, because this one's a big one. A model with a massive vocabulary might see a super long, complicated word like anti-disestablishmentarianism and go, yep, I know that one, and count it as a single token. But another model with a smaller vocabulary might have to break it down into pieces it recognizes, turning one word into 6 tokens. Just like that. Then you have the algorithms themselves. As you can see, the big players don't all use the same method. OpenAI and Anthropic tend to use something called Byte-Pair Encoding. Google uses word piece. A lot of open source models use sentence piece. They're all trying to do the same thing, chop up text efficiently. But the statistical rules they use for making those cuts are fundamentally different. And it's not just about the words. It's about everything else in between. How do you handle a space or a comma? This becomes a massive headache when you're working with code which is just full of special characters. A tokenizer that hasn't seen a lot of code will break it into tons of tiny, inefficient tokens, while one that's optimized for code will be way, way smarter about it. Okay, so that's the technical why. But now for the so what. I mean, who really cares, right? Well, you do. Because this isn't some academic detail. These tiny differences have a very real, very practical price tag that hits your budget and can even break your app. Remember that 15% token difference we saw earlier? Well, that pretty much translates directly into a 15% cost difference for the exact same job. So if you built your budget based on one model's token count, but then you go live with another, your cost forecasts are going to be wrong every single time. Now let's talk about the other huge headache this causes. Context windows. That's the limit on how much text you can cram into a single prompt. A new model might come out and boast this massive context window, like 128,000 tokens. That sounds incredible, right? You can fit a whole book in there. But there's a catch. Exactly, 128,000 of whose tokens? The actual amount of text you can fit into that window is completely different depending on the model's tokenizer. 128K tokens for GPT-4 is not the same amount of text as 128K tokens for Claude. So here are the big developer pain points this creates. First, your cost forecasting is just a guessing game. Second, managing your contacts window becomes a moving target. And third, it kills prompt portability. A prompt you carefully engineer to be just under the limit for one model could easily be too long and just completely fail on another. So what on earth do we do about all this? Well, we can't change how the models work, but we can definitely change how we work with them. Let's talk about a smarter strategy for navigating this whole messy landscape. First things first, let's just agree. Trying to keep track of this by hand, pasting your text into 5 different websites to check counts, is a recipe for disaster. It's slow, it's annoying, and sooner or later, you're going to make a mistake. The much better way to work is to use a unified strategy. You really need a tool that has all the official tokenizers integrated in one place. That way, you can paste your text once and instantly see the real accurate count for every model, all side by side. Then you can make real apples-to-apples cost comparisons and test and lock down your prompts before you ever spend a dime on an API call. If there's just one thing you take away from all this, please let it be this. A token is not a universal unit of measurement. It's not like a kilogram or a meter. It's a proprietary, model-specific unit, and you absolutely have to treat it that way. And that leaves us with a really interesting question for the future. As all these different AI models start to work together more and become more interoperable, do you think we'll eventually see some kind of universal token standard emerge? Or is this complex, fragmented world of different AI dictionaries just the new normal for all of us building in this space? It's a huge question, and the answer is going to shape how we all build with AI for years to come.